Welcome to Azure Machine Learning Service Overview. From this whiteboarding, you will understand the basic concept of Azure Machine Learning Service. Since Azure Machine Learning Service has many different parts and components, I think the best way to learn its concept is first understand the typical data science work environments, and then I'll tell you how Azure Machine Learning Service can help you to be more productive, to have more agile data science environment. So let's say I am a data scientist. I just joined a team to do the project. And to do the project, I have a machine that has storage and has, of course, CPU, and it has GPU. And I will choose a operating system, could be Windows, Linux, or Mac. And then I'll install my favorite framework to do my job. Could be Python or could be R. And on top of that, I'll choose my preferred tools to write a code and to do my work. So since the machine is ready, what I'll do next is I'll talk to DBA inside our organization to ask permission to access a table in a database. So with a proper process, I was able to get some subset of data from my data warehouse. Since I have a data, I feel I need to organize this better for my project. So first, I'll create a folder called project. And under this root folder project, I'll create a folder called data. And then I'll save my data as a CSV. Since this is a raw data, probably after a couple of experiment, couple of EDA process, probably I'll have some clean data set right before model training. So in order to automate this, getting the data, prepping the data, I realized that I can write it in a code. So I create another software called code, and I wrote a Python script to read a file from the table of database, data warehouse, and then run some jobs to clean the data set and then make it more appropriate for a model training. Since we just talked about the training a model, right after data is ready, I'll write some Python script to do a model training, and then I'll do some evaluation to select the model. To select the model, probably I need to keep those models on my local machines. So after the evaluation, I will create another folder called the model, and then I will have v1 pickle file. And then after the other training, maybe different algorithm, now I have a model or v2 in a pickle format. So we have a lot of artifact here from the sample data, code, and model. So I realized that I need to document it everything so that I can keep up, and then I can understand like what I've done so far. So I'll write a documentation called readme in a markdown file format. It could be any type of Word format to describe my project goals, data and EDA findings, and then a model that I choose, and then model that I saved after model training. And last but not least, I will just capture all my environments, the version of the Python, the version of the packages, and everything needs to be saved as a YAML file so that I can reproduce the same model or similar model afterwards. So this is my environment, and let's say got teams doing a good job. Everybody recognize our improvements. So we decide to hire more data scientists in our team. So we have 2 more data scientists in a team, and we decide to use or share our artifact through network file system. So we create another folder, and then we decide to share our project. So first of all, I will upload my files, and my colleagues will download or copy the file from our share folders. Whenever they make changes, they will do the same. They will upload it, and then I will download it from this central repository to access to others' work. So this is typical could be a typical environment where you're working as a data scientist. Couple of challenges you will face from this environment is, first of all, sharing your artifacts. So one of your data scientists, or if I forget to upload my files to this file system, network file system, others cannot access to my artifacts at all. And the second challenge you will see is, since the model is persist on my local machines, I need to find a way to move my artifact from my local PC to others to operationalize it. And then the challenge that will come after this operationalization of the model is that monitoring, in other words, having some observabilities around the operationalize the model. And also there's a lot of challenges like doing some real-time inferencing or batch inferencing, because your local machine is not scalable. Your machine is not able to run web services to support real-time, at the same time provide a batch scoring. Even scalability won't be supported in this environment. So what you need from this environment is a service or some kind of a platform that can support collaborations between data scientists in a team, and then provide a scalable environment, not just the inference but also training but also inferencing. So let's talk about Azure Machine Services, how Azure Machine Services can provide an environment where you can do collaboration seamlessly across different data scientists or even the different teams, as well as how to support the scalability for your model training as well as inferencing. So let's dive into Azure Machine Services from now on. So from this on-premise environment, if you move to Azure, and then you can use Azure Machine Services. No, good news is that Azure Machine Services will provide a same infrastructure environment that you had with your laptops. So for example, you can use storage services that provide by Azure. One of the most common storage services will be ADLS Generation 2, which is disk or storage services where you can pull, save any size of data for your data science work. And of course, traditionally there has been a storage account, which is blob storage, and you can use relational database. You can use managed database such as SQL Server or MySQL or etc. And on top of these storage services, you can choose a compute to do your train. Typically, you can imagine, or simply you can imagine, you can choose virtual machines for your training or your inferencing, which support CPU, not just single core, but multi-cores will be available. Machine that has the few gigabytes of memory up to literally terabyte size of memory will be available for you. And of course, the machine that comes with the GPU will be available for your training as well as inferencing. In addition to that, what you can use for especially inference is FPGA, field programmable gate array that will be available for you, especially if you need ultra low latency inferencing. So if you have a model that trained on top of BGG or ResNet, like a deep learning model, you can bring your model to FPGA so that you can have ultra fast inferencing for you. So the difference between this VM and FPGA is, FPGA is only available for inferencing. And then next is a framework. So here from Azure Machine Services side, you can use still Python or R. So if you have existing code such as data preparation, training, evaluation, actually you can upload to Azure Machine Services, and then you can execute those scripts that you wrote from your local machines. And on top of that, the tools perspective, Azure Machine Learning Service provide a notebook. So notebook you are already familiar with. And also we provide just not only Jupyter notebook, but also you can use a built-in notebook that is provided by Azure Machine Services itself. So if you're a code first data scientist or enterprise grade data scientist, you can use this notebook. But if you're not familiar with writing a code, what you can use is AutoML. AutoML is a very interesting feature of Azure Machine Services. Even if you are not familiar with writing a code in Python or R, even if you're not familiar with the algorithm for the particular machine learning task or even deep learning task, by just following the wizard, you can train a model with your own data set, and also you can deploy the model to operationalize it. And there's another tool you can use we called Designer. So this Designer tool will help you to define the training by drag and dropping some of the component that is already built into measurement service. Of course, you can bring your own components into the Designer, but as a starter, you can just use a built-in Designer to do some classification, regression, or recommendation model training, and even deployment of the trained model will be possible within this graphical user interface. So as you can see, your existing environment, your on-premise environment from the storage of the tool, will be exactly same environment will be available within Azure Machine Learning Services. Then what is the extra capabilities? What are the benefit you can have by leveraging Azure Machine Services? Let's talk about that. So on top of these infrastructures, the first thing you will use before you actually do some training, let's talk about data. So there's a concept called data store on Azure Machine Learning Services. So this data store is just nothing but storing connection string to allow you to access the storage layer. For example, ADLS, blob, or your relational database such as SQL Server and etc. The important part of this data store is you don't need to hardcode your ID password to access the source. So for example, accessing the data, sometimes you might need to hardcode IP address of your sources, or sometimes you need to hardcode ID or even password to automate the things from your local machines. But on Azure Machine Learning Services, you can have a secure and safe data science working environment, because data store will have a connection string, and then a password secret will be safely stored to Azure Key Vault. So Azure Machine Services has integrate with Azure Key Vault. So whenever you add those data stores that referencing one of the storage services, will automatically leverage Azure Machine Learning Azure Key Vault AKV to safely keep your secrets or password for you. Then how to access data source? In order to access the data source, there's another concept called data sets. This data set is it's a service or an object in a code level that can help you to access the data that's sitting inside ADLS. So you can describe or define the file folders or subfolders or files or just a file as a data set. Data set will help you to keep the version of the data. So whenever data is added or appended or new file is created or new subfolder is created, whenever you register the new data set with the same name, it will increment the version of that particular data set. So when it comes to retraining the model, when it comes to reproduce the model that you have a year ago, month ago, or day ago, just by providing the same data set name and then that version that you use for that training, will you can access the exact same data set again. And not only that, it provides a data profile. So when you register, you can just opt in the automatically reading your file from top to bottom, end to end, and then it will give you some description of data. So how many columns, how many rows, how many missing values, or the min or max or average of columns and data. So it will automatically give you a profile of your data set, so you can minimize your time when it comes to EDA. And last but not least, the third feature data set can provide for you is data drift. So data changing, right? Especially time series data, data. You can see how data is being changed, like weather or temperature throughout the year or day. Those data is changes, especially with the timestamp. And in order to understand how data is drifted from the data that you use for the original model training compared to the latest data or your target data set, you can just use a data set and then provide just two different data sets, baseline and then target line, and then it will automatically calculate the distance between the baseline versus the target, and then you will have some kind of index we call the magnitude of the data drift, so that you can understand how data is drifted, whether this is really changed or not. Therefore, you can make easy decisions whether you need to retrain the model or not. So dataset provide three different features: the version, profile, and data drift. It's very useful. And then once you have access through this data, what you will do is you will do some EDA using Notebook. So let's say you will do some EDA, meaning you will have access the data and then see how data is distributed, and then you will see you will check missing values, or you will check data profile, and then you will do some data engineering as well. So what you will do is maybe you can write or save your clean data set as another version of a data set. So after the EDA, the next step is actually training. So before we talk about the training, let's say this is the part where you're doing or working on the data set. From this part will be model training. So in order to training, you will write some kind of script. So for my case, since I'm familiar with the Python code, I wrote a Python code and then use a scikit-learn or some model algorithm framework to train the model based on the data that I referencing as a data set. And while I'm writing a code, I was able to capture my environment as a YAML file. Could be YAML file, could be text file based on the environment that you choose, like Conda or typical Python. So let's say I was able to capture it. And same thing can be happen on Azure. So what you can do, you can register your environment as an environment object or a part of Azure Machine Services. Meaning you can just simply or literally just upload this YAML file that you had to Azure Machine Service as an environment, and then what Azure Machine Service will do is provide the exact same runtime environment for your training in local or inside Azure Machine Services, but also compute cluster. So there's a concept called compute cluster. It's a very scalable environment. It could be one or multiple node in a cluster, so you can run your training in parallel or sometimes distributed manner. So in order to have exact same environment for each machines, the key part is having the environment on Azure Machine Services. Not only having the having the same environment for your training or for your scalable training environment, but also by just sharing the name of the environment, not only you but also your other colleague data scientists can have exact same environment on Azure. So it will help you to share exact same environment, help you to reproduce your model regardless of your Python versions and so on. So you will have exact same environment always inside Azure Machine Services. And with my code, with the environment definition, what I was able to do is submit a code in a cluster, and this cluster will set up the environment, and then we'll start this Python script, and then train the model. And after training, what you will have is a lot of metrics, right? You may have no particular metrics you're focusing on, like AUC or RSME. Those metrics will be captured from this training. So in order to capture those metrics, what you can use inside Azure is we called job. So the job will help you to capture your metrics and your artifacts, and even all this code that you wrote here will be captured as a run under the job. Meaning, even if you're not available, even somebody just went to vacations and cannot be contacted, then still you can come to Azure Machine Learning Services and look up what the other data scientists done, or what code were used for this particular model training. And not only code, of course, you can access the metrics to pick up the best model for your task. So after capturing or comparing the runs and look up the metrics, and the next thing you will do is register your model in Azure Machine Learning Services. So from this writing a code and capturing the outputs from the model training will be happen in under the training phase. And once you register model, it's everything is about operationalization, model deployment. So let's say we need to deploy this model. Of course, the model can be one or more, but let's say we have just one model here from this training. And the important, the typical pattern of the model deployment is actually the two patterns are available. One is real time. The other is batch. So for example, in case of the real time is there is a user who has Power BI or some kind of reporting tool, and this user expects some kind of web services, or let's say just some kind of endpoint where they can make a request to make a predictions, and then the response, including prediction, will come back to the users. So in order to run this endpoint, what you can do from Azure Machine Services is that you can deploy this model as a web services with a few clicks. And behind the scene, what will happen for this the deployment is that the model and then the environment will be containerized and then register inside your ACR, Azure Container Registry. So where this Azure Container Registry came from? So when you create Azure Machine Learning Services, it will create couple of services such as AKV and ACR and blob storage to log this metadata and then output and everything. So ACR will be automatically created, or if you have existing ACR as a container registry, you can use it. So the point here is that when you try to deploy the model, Azure Machine Learning Services will make a new Docker container, a Docker container that has this the model file, of course, this model and the environments. And from here, what you can add is your business logic, which could be a Python file. So you can have a Python file how to interpret the given request and then make a predictions and how to return the result back to the users. So Azure Machine Learning Service will help you to build this Docker image, and then we'll help you to deploy this endpoint. Even there's a concept called managed endpoints where you can orchestrate or manage the deployment for with the many models. Meaning, you may have the one endpoint that running model v1 and have the another deployment inside this management endpoint as with a model v2, and then you can control the traffic between these two model 1 and model 2 to see which model is accurate and better for the users. And of course you can change the traffic like between 0 to 100 to control the traffics for each models. The next option is the pattern is batch. So the batch, in order to use your model in a batch, of course you can use Azure Machine Learning Services alone, but the best way or the recommended way is using Azure Data Factory. Azure Data Factory is a separate other services. It won't be created with the Azure Machine Learning Services. So with the Azure Data Factory, what you can do is you can define a pipeline that reading data from the source and then bring the model inside a pipeline and then save the result as another table that including your prediction. So therefore when user access to Power BI or reporting tool, they can access this particular table in a database or data lake to see the result, prediction result. So this will be data pipeline. They can trigger or they can run by Azure Data Factory. There's another concept, but I won't talk about the detail about this other option inside of AML for now. So from here to here will be the typical pattern for the deployment. So by having Azure Machine Services, I've already touched a couple of benefit already, but just let me quickly recap. So from the on-prem environment, in order to capture your artifact and then share the artifact with the other, you need to rely on some other services such as file system. Maybe you could use SharePoint. You could use email even, but it's not really efficient, especially if you want to have agile or fast experiment and then share the result of experiment with the other data scientists in a team is not really efficient. And also when it comes to model deployment, it's very hard because you have another separate machines next to your training or coding environment to operationalize it. But inside Azure Machine Learning Services, of course, it provides the exact same infrastructure, from the storage to the tool perspective, and even in addition to that, it provides automated machine learning as well as a designer. So depend on your skill set, your preference, you can choose code first, notebook environment, or drag and drop or automated machine learning for your job. And not only that, when it comes to accessing the data for your training and then before your EDA or inferencing, you can use concept called data store and data set, which will provide a secure way to access your source, and then provide a version of the different data and the profile of data, as well as data drift will be provided for you. And Azure Machine Learning Service provide a scalable training environment. So of course you can use just a single machine or a compute instance or just single machine in a compute cluster. But if you want to run some hyperparameter optimization, or have a model selections by leveraging different algorithms and so on, you can use a compute cluster and then run your training in parallel. Or sometimes if you're familiar with Horrible or some other distributed training framework, you can use this compute cluster because it support MPI for distributed training for your data science work. And after training, it will capture the job, and then you can have metrics, and even it visualize the metrics. So now you don't need to write your result in a markdown file or Word file or PowerPoint file to share your findings. You just upload, or you just run a training, and then Azure Machine Learning job will capture the artifact for you, and then you can have a visualized dashboard where you can share your thoughts and idea with the other data scientists. So even your local machine is not available, even if you're disconnected, other data scientists will access your work, and then even they can see the results of it. And when it comes to model deployment, this is where Azure Machine Learning Service can help you to operationalize your model. So there's two patterns, real time and the batch. So real time, you can use manage the endpoint to deploy your model, so that the users can make a REST call to make a predictions. The other pattern is using data pipeline, so it would be a batch mode, could be nightly, could be hourly, could be any scheduled based data pipeline. So Azure Machine Services, the model, especially model, can be accessed by the activity in a Azure Data Factory pipeline. So meaning you can define activities in the read, select the table, and then run some prediction, and then save the result back to the targeted data warehouse or database, so that users can just consume from their preferred report. Okay, so far we talked about how to use Azure Machine Learning Services to access the data, to train the model in scale, and then how to deploy the model. As you can see, this reading the data and work on the data, train the model, and deploy the model, like for real time or batch. This you will see, you will find yourself you are doing or repeating this or follow this step over and over. So what you can do is you can define or have some kind of Python file that is accessing your data source through data store, data set, and then you can define that process in a Python file. And of course, the training can be also defined as a Python file. The model deployment can be defined as a Python file. Under the hood, the reason why this is possible is because Azure Machine Services provide Azure Machine Learning Service SDK for Python or R, meaning you can define how to access the data, train the model, capture the training, the metrics, and then deploy the model from Azure Machine Service to AKS or managed endpoint or AKS is possible because there's a SDK. Since you could define this process, what you can do is you can define this process as pipeline. So accessing the data, training the model, and deploying the model can be defined as AML pipeline. So the beauty of this AML pipeline is, even if you're not there to hit the enter to read the data, train the model, deploy the model, what you can do is, or other can do is, you can call the REST, use a REST API call to execute this AML pipeline, which include the reading the data, train the model, and deploy the model. The series of jobs will be automatically started whenever you call this the endpoint using the logic app or function, or maybe Azure Data Factory, or maybe your custom scheduler that you have inside your on-prem data center or your laptop. So as long as you can access to this Azure Machine Services as a reader or the owner, and then call this REST endpoint, you can run this pipeline that include this typical data science work. So now you can have a way to automate or run this job automatically. Why don't we have this Python file in a GitHub? So what you can do, you can bring this files into a repo, and then even define another code that defining this AML pipeline in a centralized Git repo. And whenever data scientists work at PC, they will download or clone the repo and then push their changed code to this centralized repository. What you can expect from here is you can do CI/CD from your machine. So what it means is, whenever you change the code and check in the code into the repo, and one of your lead data scientists or another data scientist make a pull request, then this pull request can trigger some GitHub action or a release or a build and release pipeline inside ADO, which will eventually get the data, do some code check-in, and then run this part as a CI. So read the data and then train the model and register model. And then after that, this repo will pick up the model that is just registered, or the model that has highest accuracies among the other models, and then deployed in a targeted platform can be done inside this pipeline. So by having this repo and then using Azure Machine Learning Services can give you ability to implement MLOps inside your organizations. So in order to have true MLOps, you need some kind of central repository to manage your code, and then define the CI/CD pipeline to train a model and then deploy the model. And this code can be automatically executed on top of Azure Machine Learning platform as a AML pipeline. In order to have or implement this MLOps inside your organization, we need not just one man could do. So we need at least three different persona. First of all, data scientist and data engineer, and then software engineer or DevOps engineer. So data scientists will clone the repo and then work on algorithms and try their best to find the most appropriate model for the business matter. At the same time, a machine learning engineer will help this data scientist to define the AML pipeline or do some work regarding the code for the training and the model deployment, define the score file, and software engineer needs to chime in to define this CI/CD pipeline. So in order to have true MLOps, data scientist, data engineer, and software engineer needs to be work together to implement this MLOps for the agile data science project work on a cloud. From this whiteboarding session, you learned about the basic concept of Azure Machine and Services. Hope it was useful. If you liked, please hit the like button. If you have any question or comment, please feel free to use a comment below. Thank you.